next problem is a jetliner traveling northward is landing with a speed of 69 meters per second. Once the jet touches down, it has 750 meters of runway in which to reduce its speed to 6.1 meters per second. So it starts out 69 meters per second, going north. That's about 140 miles an hour, and that's supposed to reduce its speed to only 6.1 meters per second. That's only 13 miles an hour in a total distance of, what is it again, 750 meters. And that says compute the average acceleration, magnitude, and direction of the plane during landing. Well, the direction should make sense again, that if it's going north, positive, slowing down to another positive number, well, that means that the acceleration has to be in the opposite direction. That would mean south, so we should come up with that the acceleration is to the south and that it will be negative. Okay, so here's the information that's given: 750 meters. The velocity, the final velocity is 6.1 meters per second. The initial velocity is 69 meters per second. And the acceleration is what they're asking for. Again, we look for an equation that incorporates acceleration and some or all of the information of the others, from the others that are given, but not time, because time is not given. Of the four equations, there is actually only one that does not include time, and that is 2.9. And that says v squared equals VO squared, initial velocity squared, plus 2 times acceleration times x. In this case I use the y because of the north-south deal here. Okay, I'm supposed to solve for acceleration, so I already know that I get myself a fraction bar. And as I'm solving for acceleration, I'm going to have v squared minus VO squared divided by 2y. And as I had mentioned before, it's your responsibility to be able to follow my algebra respectively. Of course, do it yourself. And then here's the result that you have to calculate. Let me just check one thing, and that is that I subtract the square of a large number from the square of a small number, so the denominator will be negative. The denominator will be negative. The numerator will be negative. That's why I paused. The numerator will be negative, and I might have mentioned that in the previous problem somewhat incorrectly. I pointed to the right thing, but I might have mentioned the wrong thing. So anyway, the numerator is negative. The denominator is positive because the machine is landing north, so the 750 meters is positive. So overall we're going to come up with a negative number, and that's what we decided earlier. The acceleration has to be towards the south, and we consider that to be negative. The next problem says a penny is dropped from rest from the top of the Sears Tower in Chicago. Considering that the height of the building is 427 meters and ignoring air resistance, find the speed with which the penny strikes the ground. So it's dropped from rest. Oh, it's a penny. Okay, I guess I used a $1 Sacagawea. I hope I pronounced that correctly. It starts from rest, so the initial velocity is 0 meters per second, and it drops a distance of 427 meters. And because it's going down, I consider that distance to be negative because it is going down. Let's see. Then I'm supposed to figure out what the velocity is just before impact. So I'm going to put a question mark here. That was supposed to be a question mark, and this one here is negative 427 meters. And the initial velocity velocity from rest is 0 meters per second. And now we also need, we don't have the time given, but we need to look closely at the problem and say, hey, this is meant to be in free fall, and with free fall we know that the acceleration is given as the acceleration due to gravity, negative 9.80 meters per second squared. The acceleration pointing down, that's why it's negative. Notice again I'm using the y, I'm the vertical, so I'm using the y rather than the x, and of course in the some of the earlier examples I only used the y because it said north and south. Anyway, I have to look for an equation that incorporates the velocity, the final velocity, and some or all of the other information, but not time itself. And that will also be the last equation from the kinematics 2.9, which says v squared equals initial velocity squared plus 2 times acceleration times distance y. That v0 over here actually comes out to 0 because it starts from rest. And then I have to solve for v, so v equals the square root of 2ay square root equals, and I underline that. Okay, now a couple of things to point out. Notice that the acceleration is negative and that the distance is negative. That means under the square root I get a positive number, and that's important because I can only take square root of a positive number, and it naturally happens so because I have to consider both the distance as it goes down to be negative and the acceleration, because acceleration due to gravity is always down, to be negative as well, so square root of a positive number. Now with the square root itself, it's going to give me two answers, right? It's going to give me positive or negative. I have to choose one of them. Well, just before impact it's still going down, so of the two possible answers I have to choose the negative part. The positive one would mean that it could rebound, but it's not going to rebound with the same velocity upward because it's not an elastic impact. You will see that you come up with an appreciable velocity just before impact, and that's why you in fact are not able to throw anything down at the top of the Sears Tower. It's completely enclosed in glass.